Humanity once expanded its vision beyond the planets. We moved past the orbit of Mars, traveled farther than Saturn, and for the first time, reached the edge of interstellar space. But today, we are standing at the possibility of closing a door, not because curiosity is gone, not because the questions have been answered, but because the only machine still out there is slowly falling silent. Voyager 1. So, what is really happening to Voyager 1 right now? Before talking about the latest updates, it helps to pause for a moment and remember just how unlikely Voyager 1's survival already is. From the very beginning, this spacecraft was never meant to still be here today. Voyager 1 was designed and built in the 1970s, during a time when no one imagined a machine could operate for decades beyond the edge of the solar system. Its original mission was simple and short by today's standards. A few years of planetary flybys. Then, silence. Inside Voyager, there are no powerful computers, no adaptive systems, no modern processors. Its computing power is weaker than a basic calculator. Its memory is smaller than a single image file on your phone. Every command it follows is rigid, pre-written, and limited. The only reason Voyager 1 is still alive at all is a power source that has been slowly dying since the day it launched. Its electricity comes from a nuclear battery that cannot be recharged, repaired, or replaced. Each year, that power fades a little more, and nothing can stop it. As that energy has declined, instruments have gone silent, one after another. Sensors that once measured particles, radiation, and cosmic environments have been permanently shut down, not because they failed, but because there simply was no power left to keep them alive. What remains today is not a powerful explorer searching for discoveries. What remains is something far more fragile. A machine stripped down to its bare essentials, quietly listening at the very edge of space, holding on just long enough to send back one last stream of truth. And that is what makes the present moment so extraordinary, because a spacecraft that fragile, that limited, and that old should not be surprising anyone anymore. And yet, it still does. So how does a machine this old still manage to surprise anyone at all? We often picture the edge of the solar system as a quiet place, empty, dark, and calm, a final stillness where nothing really happens. But when Voyager 1 crossed that boundary, it showed us how wrong that picture really was. What it entered was not emptiness, but a complicated, restless environment. Beyond the heliopause, space is shaped by invisible forces pressing against each other. Pressure from interstellar plasma, remnants of the sun's influence, and magnetic tension that stretches and bends over enormous distances. This region does not react instantly. When the sun releases a powerful storm, the effect does not arrive right away. It travels outward slowly, sometimes taking months or even years before Voyager feels the change. Instead of smooth transitions, Voyager detected sudden shifts. Particle densities jump without warning. Conditions flip abruptly, defying the early models that imagined a gradual fade from solar space into interstellar space. The magnetic fields out there behave differently as well. They are steadier than inside the solar system, but they point in unfamiliar directions. Familiar rules no longer fully apply. Voyager is not just far away from Earth. It is moving through a boundary zone that science never fully mapped before, a place where definitions blur and assumptions quietly break apart. If the environment itself is unstable, what does that mean for the data Voyager sends back? Silence in deep space sounds terrifying. When a spacecraft stops talking, It feels like the end. But for engineers, silence is not always the most frightening scenario. Temporary signal loss can happen for ordinary reasons. A slight shift in antenna alignment, a scheduled outage at a ground station on Earth. Even the slow rotation of the spacecraft itself can briefly interrupt contact. What truly worried engineers was not silence, but noise. The signal from Voyager 1 was still reaching Earth, strong enough to detect. But the data inside it stopped making sense. Telemetry streams that once showed clear temperatures, voltars, and system states turned into meaningless numbers. Values repeated, jumped randomly, or appeared in places they should never exist. This was a crucial distinction. A communication problem affects the signal. A data handling problem affects the spacecraft's ability to understand itself. Voyager was talking, but it no longer knew how to describe what it was experiencing. At that distance, every diagnosis becomes painfully slow. A command takes more than a day to reach the spacecraft. The response takes another day to return. Every test costs time that Voyager may not have. So what do you do when a spacecraft is talking, but not saying anything coherent? The most important moment in this story did not involve a new discovery from space. It involved a decision made on Earth, a quiet, technical choice that carried enormous risk. Engineers eventually traced the problem to a corrupted memory region inside Voyager 1's flight data system. Not a broken instrument, not a failed antenna, but damaged memory where critical software lived. This section of memory controls how raw sensor readings are processed. It decides how numbers become meaningful data before being transmitted back to Earth. When it breaks, the spacecraft can still measure reality, but it cannot explain that reality to anyone listening. The solution was not a reset. It was not a reboot. Engineers had to rewrite parts of the flight software and move them into unused sections of memory that had never been activated during the mission. This kind of operation was never meant to happen at this distance. Commands take more than a day to arrive. Confirmation takes another day to return. Every step is blind, slow, and irreversibly. One incorrect command could overwrite working systems. One misplaced instruction could permanently silence the spacecraft. There would be no second attempt, no physical repair, no rescue mission. This update was not dramatic because of what it discovered, but because of what it risked. Engineers chose to act while Voyager could still respond, knowing that doing nothing would guarantee a slow and silent end. Why risk everything now, instead of letting Voyager quietly fade away? This was not routine maintenance. It was controlled improvisation, the kind that only happens when there is no manual left to follow. Only judgment and experience. The engineering team had to rely on documentation written decades earlier. Some of it dated back to a time before personal computers were common. Every page mattered. Every assumption had to be questioned. In some cases, system behavior was only partially understood. The people who designed those subsystems had retired long ago, and the reasoning behind certain choices lived only in aging notes and institutional memory. There was no real-time feedback. After sending a command, the team had to wait more than 22 hours before knowing whether Voyager 1 had accepted it or rejected it. Every step forward came wrapped in silence. The spacecraft itself was operating in conditions it was never tested for. Temperatures had dropped far below original design limits, pushing components into unknown territory. Stability could not be assumed. And yet, the update worked. After months of confusion, the data stream became readable again. Numbers regained meaning. The spacecraft could once more describe its environment instead of whispering nonsense. This was not a victory of technology alone, but of patience, memory, and careful restraint. A reminder that sometimes progress means fixing something almost 50 years old. But what exactly did this fixed data begin to show? The update did not reveal anything dramatic. There were no explosions of data. No sudden anomalies that rewrote physics overnight. What it revealed was something far quieter. And far more important, once the data stream stabilized, plasma wave readings began to show variations that had been hidden before. Small shifts in frequency and intensity that were previously buried under corrupted noise became visible. Particle counts outside the heliosphere also looked different. Not higher, not lower, but more organized. Patterns emerged where randomness was once assumed, suggesting structure in a region thought to be mostly chaotic. The magnetic field told a similar story. Its overall direction remained steady, just as earlier measurements suggested. But the way it interacted with particles had shifted subtly, revealing relationships that were previously blurred. None of these were new phenomena. They had always been there. What changed was not space itself, but our ability to listen without distortion. The repair did not create new science. It removed the static. In that sense, Voyager 1 was not discovering something new at all. It was finally hearing the same environment clearly. After months of listening through interference, why does clarity matter more than novelty at the edge of the solar system? Voyager did not just cross a physical line in space. It crossed an idea humanity had held for decades about where the sun truly ends. For a long time, scientists imagined the heliopause as a clean shell, a boundary like the surface of a bubble, separating the sun's domain from interstellar space. Voyager showed that this picture was too simple. The data revealed a layered structure instead. The heliopause behaves more like a breathing boundary, expanding and contracting as solar activity rises and falls. It is not fixed. It responds. The sun's influence also fades unevenly. In some directions, it stretches farther into space. In others, it collapses more quickly, shaped by past solar storms and the surrounding interstellar environment. Outside the heliosphere, pressure from interstellar space pushes back harder than models once predicted. The galaxy is not a passive backdrop. It actively presses against the sun's magnetic bubble. This realization matters for the future. It changes how scientists think about radiation shielding for spacecraft that travel beyond the sun's protective influence. The boundary is weaker and more complex than expected. In a deeper sense, Voyager 1 forced scientists to rethink the meaning of inside and outside. The solar system does not end. It fades. If even our sun's boundary is blurred, how many other cosmic borders are illusions? By this point, Voyager 1 is no longer just hardware drifting through space. It has become a responsibility shared across generations of engineers. To keep it alive, teams have had to make painfully careful choices. Heaters are shut down. Backup systems are powered off. Every fraction of a watt is treated as precious. As a result, components now operate at temperatures once thought impossible to survive. Parts of the spacecraft are colder than anything they were ever tested for on Earth. Every command sent to Voyager is debated and simulated in advance. Engineers ask not just whether a command will work, but whether it is worth the risk of sending it at all. There are no dramatic hero moments in this phase of the mission. No countdowns. No celebrations. Just long meetings. Careful restraint. And the discipline to do nothing when doing nothing is the safest choice. The goal has quietly shifted. It is no longer about discovering something new. It is about preserving what still works for as long as possible. How long can patience keep a machine alive in deep space? Nothing dramatic is waiting ahead for Voyager 1. There are no final encounters planned. No sudden discoveries hiding just beyond the horizon. At its current speed, the spacecraft will take centuries just to approach the inner edge of the Oort cloud. Even that milestone will pass without any noticeable change. Voyager will never fly close to another planet or star. Its path leads through vast regions of empty space where nothing interrupts its motion. Power will continue to decline year by year. Instruments will shut down one at a time, not because they fail, but because there is no energy left to support them. One day, the signal will simply stop. There will be no warning, no final message, no moment that feels like an ending. After that, Voyager will keep drifting, silent, intact, and unseen. A small object carrying the memory of where it came from, moving through the galaxy forever. If the journey ends without an ending, what meaning does it leave behind? Voyager 1 was never meant to carry meaning. It was built to collect numbers, transmit signals, and quietly follow physics out into the dark. And yet, over time, it became something else. It became proof that curiosity can outlive intention, that machines can travel farther than the questions they were designed to answer, and that humanity is capable of sending a fragile idea into a place it may never fully understand. What Voyager gives us now is not a final discovery. It gives us perspective. It reminds us that the universe does not end cleanly. Boundaries blur, definitions soften. Even the edge of our own sun turns out to be more complex, more alive than we imagined. Soon, Voyager will stop speaking, not because it failed, but because it gave everything it had. And when the signal fades, nothing dramatic will happen in the sky. No light will go out. No chapter will visibly close. But something important will have changed. For the first time in history, humanity will have no active presence beyond the sun's influence. No listener at the frontier. Only memory, data, and a silent traveler moving onward without us. Voyager does not ask to be remembered. It does not announce its ending. It simply continues, obeying the same physics it always has. And maybe that is the most human lesson of all. That exploration is not defined by how loudly it ends, but by how far it was willing to go before falling silent. So when we ask what Voyager leaves behind, the answer is not technology, or data, or distance. It leaves us with a question we are not finished answering yet. When the universe finally grows quiet again, are we ready to listen to what that silence means?